Hi again. In this video we're going to look at how to do Jefferson's method. So we're continuing our example of math instructor positions apportioned among the 4 campuses of PCC of different sizes. And like I mentioned in the last video, the first 2 steps are the same. So our total is the same, our divisor is going to be the same, 23,231 divided by 45, which is 516.24, and then we divide each campus by the divisor, and that gives us our standard quota. So I'm going to copy our numbers from our Hamilton's example. Okay, so first 2 steps exactly the same. Now let's see what Jefferson said to do. Jefferson's method was actually used before Hamilton's. It was used from 1792 to 1830. He said, cut off the decimal to find the initial number, same as Hamilton, but then lower the divisor if needed, so there are no leftover seats. This method uses trial and error. So Jefferson didn't think that it was really fair to just say, oh, whoever has the highest decimal gets 1 whole extra representative. He thought that we should take this divisor and lower it until this comes out to the exact number that we need. Okay, so let's try it and see how this works. Okay, so we're going to have our initial number, just like in Hamilton's, we had our initial number. So I'm gonna leave space for several columns here because we're gonna have to try some different divisors. So I'm gonna write initial number, and that's what we had before because we cut off the decimal still, 17, 9, 13, and 5, but we know that adds up to 44. Okay, so we are not done yet. So what we need to do is try lowering our divisor to see if one of these will bump up and give us 45. So I don't know exactly what it should be. What I'm going to do is take a guess and lower this to kind of a round number. This is 516, so I'm going to try 500. And I like to write what I'm dividing by here so that I can remember, since it's a trial and error process. Okay, so let's start back over. We need to take each campus, place to put my calculator here. We need to take each campus and divide by 500. So 8,871 divided by 500 is 17.74. You can see we're dividing by less, so we get a little bit higher number. Let me move this up. I think that'll help. Okay, great. So now let me divide cascade. 4841 divided by 500 this time, which is 9.68. Okay, 6797 divided by 500 is 13.59. 2722 divided by 500 is 5.44. Okay. Now remember, just like Hamilton's, we cut off the decimals, so you can just imagine cutting these off. And then we need to see if we are up to 45 or not. And I see 17, 9, 13, 5. None of these bumped up, so we're still at 44. Okay, so 500 didn't work. We need to lower it more. Okay, so I'm going to try dividing by 490. I usually try to go by a 5 or a 10, but you don't have to. Okay, now we start back over here. 8871 divided by 490, which is 18.10. Okay, now we're getting somewhere because this is now bumped up to 18. Hopefully none of the other ones bumped up because we only have one extra. So let's check. 4841 divided by 490 is 9.88. Okay, so that stayed 9. 6797 divided by 490 is 13.87. And 2722 divided by 490 is 5.56. If I round, oops, sorry, you can't see that. 5.56 rounded. Okay, now we cut off all these decimals. So we have 18, 9, 13, and 5. That should be 45, right? But it's always good to check. Exactly 45. So notice that our answer came out different from Hamilton's method. In Hamilton's method, Cascade had the highest decimal, so it got the extra one. But in Jefferson's method, Sylvania actually ended up bumping up first before any of the other campuses. So we have a different apportionment. That's why there's different methods, because some things happened in U.S. history where odd things happen when they did the reapportionment. So when we take the U.S. Census every 10 years, then they reapportion the representatives in case people have moved to different states. They want to keep the representation proportional. So some things happened where Hamilton's method had some unfair things happen, so that's why Jefferson's method was used at the beginning. But then you can see we've switched methods. Okay, so that is Jefferson's method. We have to do this trial and error process where we still cut off the decimal, but then if we don't have the exact number, we have to lower our divisor, keep lowering it until we get the exact number. Now, if we had gone too low, let's say this bumped up to 46, if we had gone too low, we'd have to go back up, and we'd know it was somewhere between 490 and 500. So this method does take some patience. So leave yourself lots of room and use lots of patience, because we would have to go in between, say, 495. Okay, that's why I recommend lowering it really gradually so you don't get to where you're going up and down, up and down. Okay, so that's Jefferson. I'll see you in the next video for Webster's method.